Good morning students. Today we are going to see about the process in operating system. What is meant by process? Process is nothing but program in execution. So whatever the program you have taken, whatever the functions you have taken, that is execution is important. So that is called the program in execution. So a process is defined as a program in execution. In here, two entities to be called in the process. First one, a program is a basic entity. Program is a basic entity means containing the list of instructions stored on a disk. And another one, active entity. Active entity means counter the specifying the next instruction to execute and a set of associative resources. So a process is more than program code, which is sometimes known as the text section. Here many sections to be called. One is a text section and a stack, data section, keep. This is a process in memory. Here you see about the stack, heap, data and test section. So test section is nothing but it includes the more than one program code, and then it includes the current activity as represented the value of the program counter and the content of the processor registers. So stack is include the contains the temporary data. It contains a data section which contains the global variables. A process may also include a heap, which is memory that is dynamically allocated during process is runtime. During the process at runtime. So here is the process in memory. Memory contains the stack, heap, data and text section. Next one, process state. Process state is executes the it changes the state. The state of a process is defined as a part of the current activity of the process. The following many of the following states are to be new, ready, running, waiting and terminator. First one, new. New one is nothing but process is being created. New process has been created in the new. Running. So instructions are being executed. Waiting. The process is waiting for some event to occur. Ready. The process is waiting to be assigned to a processor. Terminator. The process has finished execution. This is the 5 status of the process state. Next one, this is the diagram of a process state. First one, new. So the new process has been admitted to the ready for the execution. So if the process is ready for execution, then after to schedule the dispatch to the processes at the running state. The scheduled dispatches processes running state, and after going to the terminate, the process has been completed, going to exit the terminated state. In another one, running state, 3 cases to be occurred in this problem. One is the exit of the process, and another one the interrupt. So when will come the higher priority process is coming to the ready process. That process, the current execution of the process interrupted to the running stage. So the process is again going to the ready state. Then after coming to the higher priority process come to the ready state, and the scheduled dispatch stage after it has been exited, and the interrupted process coming to the ready state after scheduled dispatch to the running state and exited to the terminated to the execution of this to be process completed. And another one, some process needed to execute the some IO devices. So you have waiting for the IO and IO or event completion. So the process, when we get the processes IO and IO devices, then going to the ready state after schedule dispatch to the processes. The running state, the coming to the running state of the process has been executed completely. This is the diagram of the process state. Next one, process control block. Process control block, they have the many different control block you have. So DOS control block, process state, program counter, CPU registers, CPU scheduling information, memory management scheme, accounting information, IO status information. So this is a process control the many block process state, process number, program counter, registers, memory limits, list of open files. So first see about the process. What is meant by process control block? So each process is represented to the operating system by a process control block. Is also called as a DOS control block. It contains the many pieces of information associated with a specific process. What are the informations? First one, process state. Process state you have already know. The state may be new, ready, running, waiting, halted, and so on. Then next one, program counter. Program counter, it indicates the address of the next instruction to be executed of this process. This is a program counter. Next one, CPU resistors. CPU resistor are built in the CPU. Is also nearby the CPU. The resistor vary in number and type and depending upon the computer architecture. They include the accumulator, index resistors, stack pointers, and general purpose resistors. Next one, CPU scheduling information. CPU scheduling means so many processes available in the ready queue. Thus select any one of the process to be execution. This information include a process priority pointer to the scheduling queue. Next one, memory management information. Memory management information, it includes the such of the value of the base and limit resistors and the page tables. Next one, accounting information. Accounting information include the amount of the CPU and real time used, time limits, account number, job or process numbers. Next one, IO status information. This information includes the list of IO devices. So what are the devices are allocated to the processes? There is no about the information about the IO status information. And the list of IO devices and a list of open files and so on. These are the process control block. So what are the items that to be included in the process control block? Many of the information associated with a specific process, process state, process program counter, CPU resistors, CPU scheduling information, memory management information, accounting information, and IO status information. Next one, process scheduling. Process scheduling is many process many processes available in the ready queue. The process scheduler select an available process for program execution on the CPU. For a single processor system, there will be never more than running process. If there, so we have only one processor means more than one running process, and another one more than one processor means the rest will have to wait until the CPU is free and can be rescheduled. So the objective of multi-programming is to have some process running at all time. The CPU to maximize the CPU utilization. So the objective of the time sharing is to switch the CPU among the processes. So frequently that users can interact with them each program while it is running. This is a process scheduling. Here scheduling queue, 3 type of scheduling queues. First one, job queue, ready queue, device queue. So job queue means nothing but the processes enter into the system. So it consists of all the processes in the system is called a job queue. Next one, ready queue. The process that are residing in the memory, residing in main memory and ready and waiting to execute are helped on a list. It's called a ready queue. Next, ready queue header contains the pointer to the first and final PCBs in the list. Next one, device queue. Device queue, the list of processes. So each process that requires IO operation may have to wait for the device. Some process wait for the device is a device queue. So list of processes waiting for a particular IO device is called a device queue. This one of them, scheduling queue. The scheduling queue, 3 type of queue: job queue, ready queue, device queue. So these are the processes in OS, process state and process scheduling and process scheduling queue. Thank you.